All right, last classification area for the periodic table. All right, you are going to learn about the inner transition metals. All right, so I'll explain in a second why they're called that. But again, you want to kind of know their properties, their characteristics, how to tell them apart, give some examples, that sort of thing. So your inner transition metals, sometimes referred to as your rare earth metals, those are those elements that are actually pulled out of the periodic table and thrown at the bottom. All right. So in all reality, they belong right here in the periodic table. The reason why they get pulled out is because to move this around, all right, so like to grab this and drag it over here, and then to put this guy in the middle, that's going to make your periodic table huge. This isn't a big table this wide, doesn't fit very well in textbooks. That's why instead these guys stay in their positions as we are used to seeing them. All right. So, characteristics of inner transition metals. They are often referred to as the rare earth metals, not because they're rare, it's just that they're less well known than, say, our common transition metals like copper and gold and silver and things like that. And they also they're pulled out, they're separated because they do have different properties than our more commonly known transition metals. All right, so for example, most of them are a silvery white gray color. They are shiny, but they're hugely reactive with just water in the air and other chemicals in the air, which kind of tarnishes them. So if you ever see an example of one, it might not look very shiny, but that's because it's already reacting. So we can split the inner transition metals into two different classifications. The top row, so period 6 of the inner transition metals, are called the lanthanide series, named for the first element in that row, which is lanthanum. So these are all silver in color, but they do tarnish when they are exposed to air, which makes them look not so shiny anymore. An example is samarium, which can be used with cobalt to make magnets. And then we've got your actinide series. That is the bottom row of the inner transition metals. The unique thing to your actinide series is that they are all radioactive. All right, you're probably familiar with uranium and that its relation to nuclear reactors and nuclear bombs. And actually, just these first 4, the ones pre-uranium and before, those are the only naturally occurring ones. All right, everything past uranium, also known as transuranium, they are all synthetic or made in a lab elements. All right. So, in fact, if you look at it, if you go back into the periodic table, even all of the transition metals that would go beyond and have higher atomic numbers than 92, all of those transuranium elements are synthetic, made in a lab, not something you actually find on its own, just naturally occurring on Earth. There are your classifications of the periodic table. So definitely have a periodic table out with the color coding, have these notes out, things like that when you get to taking quizzes and that unit test that's coming up.